English or Spanish? French or German? What is the best language for math? This is a continuation of my last video called Spelling Numbers with Variables, and I recommend you watch that one first. But anyway, here's a quick recap. Writing variables next to each other means you multiply them. And if we give variables certain values, then we can spell out numbers and they'll multiply to equal themselves. And if we pick certain words, we can stack them together to get more numbers. Here we only used 5 words, but we got 12 numbers. But we want more than 12. So how many numbers can we get to multiply correctly using a single set of variables? And in the last video, we found a set in English that works for the following words. There are 2 options for the sign, either blank or negative. There are 21 options for the main body of the number, shown here. And there are 13 options for the suffix of a large multiplier. How many combinations does this make? Well, we just multiply 2 times 21 times 13 to get 546. And then also, we can use a z to make 0, so we add 1 and get 547. So we have a result for English that works for 547. But what about other languages? In this video, I'll be covering other languages that use the Latin alphabet just like English. And in the next video, I'll talk about different scripts like Cyrillic, Arabic, and Hangul. I do want to make a couple comments before I start. First, comparisons between languages are based solely on this metric. If I say a language is better, that just means we can have more numbers with one set of variables. You can be good at math in any language, and one isn't inherently better. Next, these may not be the true maximums. They are the highest that I've found, but I may have missed something, especially with languages that I'm not fluent in. And lastly, I apologize for any mispronunciation. Again, I'm not fluent in these, I'm just trying my best. So, with that out of the way, let's dive into our first language, Dutch. Now we're doing this first because it has the most in common with English. So in English we have numbers such as 7, 12, and 100. And the Dutch counterparts are 7, 12, and 100. So there's a lot of similarities. But what are the differences? Well, both languages have 26 letters. English is missing a J or K. Those letters don't appear in any numbers. Dutch also doesn't have a K, but instead they're missing Y rather than a J. But still, both languages end up with 24 useful letters. But one of English's useful letters was Z. Z only appears in 0, so it's barely useful because we can't stack 0 with anything. But Dutch has it appear in other numbers. Another difference we see in the tens. In English, if we set ty equal to 10, we get 60 and 70 and 90. But in Dutch, we get 50 through 90. The spellings are more standardized. But the main difference between these two languages is that English uses the short scale and Dutch uses the long scale. What does that mean? The scale of the number applies to the large numbers. So in short scale, we have million equal to 10 to the 6th, billion is 10 to the 9th, trillion is 10 to the 12th, and so on. Every new word is 10 to the 3 times the previous one. We're moving up by 3, 6, 9, 12. But in long scale, million is still 10 to the 6, but billion is 10 to the 12, and trillion is 10 to the 18. We're moving up by 10 to the 6 each time. But what goes in the gaps between them? Well, instead of million and billion, they are milliard and billiard. And this is very useful because this means that if we set OEN times 10 to the 3 equal to ARD, we get a bunch of words for free. Now let's compare them in a table. They both have 26 total letters and end up with 24 useful letters. But Dutch uses the long scale. So while they have a similar amount of small numbers, those that are less than 1,000, Dutch has way more large numbers, those that are 1,000 and greater. Now English had 2 times 21 times 13 plus the 1 for 0 to get 547 numbers, but Dutch gets 1,012 numbers. And we can look at that here with the bar graph to see how much larger that is. Stick around to the end of the video if you want to see the actual values for the variables and the way to construct these numbers. Alright, now let's move on to the Romance languages. And we'll start with French. Now French, just like English, has the 26 letters. But in addition to J and K, they're also missing W and Y. So I bet they're jealous of our number 20 that has both. Now English had Z only appear in 0, so it wasn't very useful. French also has letters that end up being useless because V and G only appear together. 20 is the only number that has a V, but also the only one that has a G. So these two variables are dependent on each other. They act as one together rather than two separately. Another difference between the two is that English doesn't really have plurals, but French does. So 1 million is spelled without an S, but 2 millions does have an S, and any larger amount of millions also has an S. So in English it was worth it to use the number 1, but in French it's best not to. And this use of plurals is kind of a bummer because in French, 80 means 80, but it literally translates to 4 20s. And so it appears that if we get 4 and 20 to work, we also get 80 for free. But there's an extra S at the end, which means we'd have to set S to 1. So those are a lot of downsides for French, but French uses long scale, which makes up for that. And so they end up with less small numbers than English, but more large numbers, giving them a total of 612. All right, now we'll move on to Spanish and Portuguese. And we'll look at these together because they have a lot in common. Spanish has 27 letters in the alphabet. They have an extra ñ, but ñ doesn't appear in any numbers, so that doesn't matter. Now both are missing F, J, K, and W, and then Portuguese is missing Y. Now Y only appears in Spanish numbers in the form of the word and. For example, 64, meaning 60 and 4. And I've picked this for my system because 64 is a great number, but it could have been any of the numbers from 21 to 99. Now both of these languages have plurals, which kind of creates a problem for the hundreds, where most of the hundreds follow the same pattern, but there are a few that we have to throw out because they don't work quite right. Spanish uses long scale, which is great, and Portuguese uses both scales. Brazil uses short scale, but we're not going to use that because we get a better result if we go with the long scale that's used in Portugal, Angola, and Mozambique. But the long scale for these languages is slightly different than what we've seen before. Rather than billion and billiard, we have the equivalent of billion and 1,000 billions. But functionally, it's the same. It's actually even a little better because we also get the number 1,000. Now, both have 13 small numbers, but Spanish has a few more large numbers, which gives it 756 as opposed to Portuguese's 648. Now we'll look at the final Romance language for today, and that's Italian. And let's look at the Italian alphabet. Some of the other languages we looked at didn't have J, K, W, or Y in any of their numbers. But Italian doesn't even have them in the alphabet. They only have 21 letters to begin with. And they also don't have F, H, or P in any numbers, so that's down to 18. And Z only appears in 0, so it's barely useful. Now Italian does use long scale, but that doesn't quite make up for the lack of letters, and they end up with only 451. Now we'll head east and look at Turkish. The Turkish alphabet has 29 letters. They have a number of letters for consonants such as ch and sh. Now there are 4 that are missing, but that still leaves them with 25 to work with. In Turkish, there isn't really a pattern for the tens that correspond to the single digits. We almost see this with altmış and yetmiş, 60 and 70, but it's not quite the same. And so this is the only language where it's not worth it to have any numbers from 10 to 99. And Turkish also uses short scale, so that's a bit of a hindrance, but with the number of letters, they still end up with 581, a step above English. Now we'll head even further east and take a look at Vietnamese. The Vietnamese doesn't use either long or short scale. They have Ninh for 10 to the 3, Chieu for 10 to the 6, and T for 10 to the 9. And then on from there is Ninh T, Chieu T, and T T. But any instance of a higher power of 10 that I found written in Vietnamese was just written in scientific notation. So the possibilities kind of end with DT. And this means that the number of letters doesn't matter. Vietnamese has enough letters to make all of the number words. That even means that it's useful to make fractions, which wasn't the case with most other languages. And so Vietnamese ends up with 374. It has the most small numbers, but only 6 large numbers. Now we'll head south and look at Indonesian. Now Indonesian has very straightforward naming. The name for 40 million is 40 juta, which literally means 410 million. So it's very easy to combine the words that we create. But there are 6 letters that don't appear in any numbers, so they end up with only 20 useful letters. And they also use short scale. So that leaves them with 480 numbers that work. Now let's take a look at Yoruba, a West African language. Now Yoruba has the most interesting numbering format we'll look at today. So here we have the single digits. And instead of multiplying by 10, we multiply by 20. So 20 is ogun, and 40 is ogoji, or 20 times 2. And 60 is ogota, or 20 times 3. And the pattern follows. And we get the same thing multiplying by 200, and then further on with 2,000 and 20,000. So the word for 2 billion is oke ona oke marun, which means roughly 20,000 ways of 20,000 times 5. A lot of the naming is also based on subtraction. So the word for 500 is edegbeta, which means 100 less than 200 times 3. Although subtraction doesn't work well for our system, so we won't use any numbers of this format. This is a very cool way of naming numbers, but it doesn't go very high. There isn't really a way to express numbers a trillion and up, which means that our maximum is only 192. And now the second to last language we'll look at is Polish. Now the thing that sets Polish apart the most is their use of plurals. We saw plurals before with French, Spanish, and Portuguese. But in Polish, there are 3 forms. There's one for singular, such as 1 million, and then for 2 through 4, such as 2 miliony, and then a third for 5 and up, such as 5 milionów. So this means it's not worth it to use the numbers 2 through 4. And it also wouldn't be useful for the number 1, except that that's the only place a J appears. So we would be wasting the J if we didn't. Now these plurals kind of hinder Polish a bit, but they use the long scale, which is great. And they also have 32 letters in the alphabet. Now 6 of these don't appear in any numbers, but that still leaves 26 useful letters. And that means we get a set of variables that works for 968 numbers. Almost as much as Dutch. And now let's move on to German. German has 30 letters in the alphabet, and 3 of these aren't in any numbers. But that leaves 27 useful letters. They also use long scale, and they do have plurals, but it's only the singular versus multiple. And German also has an interesting case of 2 variables having the same value. Now the tens have somewhat of a pattern. We can get 40, 50, 80, and 90. But then we can also get 30, which is 30. And this is the only German number that uses SZ, that beta-looking letter. And we want both the blue and the yellow to equal 10. And so canceling for the IG, Z and SZ end up with the same value. And now let's look at the results. With German, we can get a set of variables to work for 1,150 different numbers, which makes it the most efficient language we've looked at today. Thank you for watching. Next video, I'll cover some languages that use other scripts. Now stick around if you want to see the actual values for these variables and the different words that we use. Otherwise, bye! This is a Google Sheet that I created that has all of the information for all the languages I covered. And so I'll walk through the format of the English. The rest of them are very similar. So here in this section, we have the different types of numbers. So we have the sign, single digits, double digits, medium numbers, and huge numbers. Here in the format, this describes a way to construct a number. So this outer parentheses say this is one way to make a number. So we have one of the options from the sign, either a blank or negative. And then within the next comma, there's 2 things we could do. We could either take an option from the single digits and an option from the medium numbers, or instead, we could take an option from the double digits. And then following that, we take an option from the huge numbers. Now instead of doing all of that, we could just say 0. And below is a formula we can use to calculate the number of options based on this format. And we also see the formula recreated up here using the actual values from the cells to give us the 547. Over here on the right are calculations of the actual values of the numbers. So we can see 6 equals 6 and 100 equals 100. And if we type a different one in, like 8 million, we see that equals 8 million. Now, some words won't work, like if we say test, we get an error because we're trying to raise -1 to the 1 3/8 power. And Google Sheets doesn't like complex numbers. But this works for all of the numbers that follow the format. Now, there is one other sheet for English, and that's the data sheet. Now, this shows the values for each letter, each variable. So let's take a look at A. This means that A is equal to 2 to the power of 2 times 3 to the power of a half times 5 to the power of 3.5 times 7 to the power of -half times I to the power of 1. So we can see the same thing with G. That's 2 to the 29 times 3 to the -2 times 5 to the 27, and then nothing from 7 and I. And that holds for everything except for Z. Z is just 0, although these powers imply that it's 1, which is why it's in black. And so again, the link to this is in the description, so you may take a look if you'd like.